black holes, I mean, they're like the biggest mysteries out there, right? These massive things warping space and time, and we're still just figuring them out. But hey, remember back in 2017 when we got that first ever picture of a black hole?
Yeah. M87, that supermassive black hole at the center of the galaxy Messier 87. Such a huge moment, right? We finally got to see something we thought we could only, imagine.
Totally. And now, get this. There's new research from that same team, the Event Horizon Telescope, the EHT, and we're getting an even closer look at M87. So that's what we're diving into today, this new research, figuring out how this cosmic giant has changed since that first picture and what it all means for black holes in general,
So one of the things they found when they compared the 2017 picture with what they saw in 2018 was that the brightest part of that ring of light around the black hole, it had actually moved.
Wait, the ring of light moved, so like the whole ring just shifted over. I'm trying to picture this.
Not the whole ring, no. But the part that was like glowing the strongest, that shifted. And this is all because of the accretion disk, the gas swirling into the black hole. It's not a smooth flow, It's turbulent, always changing.
So it's more like a cosmic whirlpool than a river. But hold on, this wasn't just some like random observation, right? Didn't scientists actually kind of predict this shifting brightness?
Exactly. After that 2017 data, they figured the turbulence would make the brightest part of the ring, change position over time. And then 2018 came around and boom, there it was, confirmation.
Yeah.
Shows how powerful those scientific models are.
Yeah.
Right? And how much we're learning about what happens around these extreme objects.
That's mind-blowing. Like they looked into the black hole's future or something. Makes you wonder what other predictions are, like hiding in the data, waiting to be found. But speaking of details, there was something else in the research that caught my eye. It seems like the bottom part of the ring stayed bright in both the 2017 and 2018 pictures. Why is that?
That's a great observation. And it's actually telling us something important about how the black hole spins. Imagine a spinning top, right? Depending on how it's tilted, we see different parts of it. Well, same idea here. That constant brightness at the bottom, it tells us the black hole's rotational axis, that imaginary line that spins around. It's pointed away from us, like we're looking at the south pole of the spinning black hole.
Okay, I think I get it. So we've got this crazy turbulent disk and a black hole spinning like a cosmic top. And we're seeing all this through these amazing images. But the EHT team, they used a ton of simulated black hole images, right? Like over 120,000 of them. Why so many?
Good question. See, the area around a black hole is incredibly complex. You've got intense gravity, magnetic fields, matter moving super fast. So to understand what the EHT is seeing, they need to compare it to a bunch of different possibilities.
So they're kind of doing a cosmic lineup, right? Seeing which simulated black hole matches the real one the best.
Exactly. By running all those simulations, each a little different, they can figure out which models fit the EHT data. And that helps them refine what they know about what's going on in this extreme environment.
Like putting together a puzzle, but, a cosmic one. But here's another question that's been bugging me. Does all the gas around a black hole flow in the same direction? Or is it more complicated than that?
Well, it's definitely not a simple inward spiral. In fact, get this, the new research.
Yeah.
It suggests that a lot of the gas in M87's disk, it's actually flowing in the opposite direction to how the black hole's rotating.
Hold on, so there's gas going against the flow, adding to all that turbulence.
You got it. This counter-rotating flow, it adds another layer of, complexity to how we understand these things. How black holes pull in matter and how they affect their surroundings. Raises a whole bunch of new questions about, how this counter-rotation even happens and what it does to the black hole.
This is a lot to take in, and we're just getting started. I'm ready to dig deeper into this counter-rotating gas flow. How about we take a short break and come back to unravel this mystery?
Back again. And, it's wild to think just a few years ago, we'd never even seen a black hole. And now, here we are, talking about turbulent flows and gas going in different directions. Like, it's just, normal stuff.
Really makes you realize how fast we're learning about the universe, doesn't it? Like, black holes used to be just ideas. Now we can actually study them. And it's not just about the pictures, right? Those EHT images, they're packed with information that's helping us figure out some of the biggest secrets out there.
Absolutely. And what we're learning, it goes way beyond M87 itself. It's helping us refine our understanding of, basic physics and how galaxies evolve as a whole.
Hold on. So how does looking at one black hole, even a huge one like M87, help us understand like whole galaxies? Seems like a big jump.
Think of it this way. Supermassive black holes, they have this massive gravitational pull, right? Everything around them, the gas, the dust, stars, it's all interacting with the black hole, feeding it, but also being shaped by it.
So by studying what's going on around M87, we can learn about how black holes and galaxies work together, kind of like a cosmic dance, but with some pretty high stakes.
That's a great way to put it. The way the gas flows, the jets shooting out, the stars, it's all connected. And it tells us how black holes and galaxies grow and change together.
It's amazing to think that something as powerful and kind of scary as a black hole can also be so important for how galaxies are made. But going back to M87 itself, what was the most surprising thing you learned from this research?
For me, it's got to be that confirmation of the turbulent disk. You see, for a long time, scientists weren't sure if the gas flowing into a black hole would be, kind of smooth, or if it would be chaotic, like what we see with M87. It was a big debate.
So these EHT observations, they pretty much settled it then. M87's not a peaceful place.
Nope, not at all.
Yeah.
That shifting brightness and the gas going in opposite directions, it all points to a very dynamic environment. It's constantly changing.
That's incredible. It changes how we think about what's around a black hole. Why is this turbulence so important, though? What does it tell us that we wouldn't know otherwise?
Well, the turbulence, it affects how the black hole pulls in matter, how it grows over time. And it also affects those jets we talked about.
Oh, right. The jets. Those were a big deal when that first image came out. They kind of change how we picture black holes, not just sucking everything in.
Definitely. Understanding how those jets form is a big part of black hole research and the EHT observations. They're giving us so much data to help with that.
So everything we learn about M87, the turbulence, the spin, it all adds to the bigger picture. Helps us understand black holes and how they affect, everything. And it's amazing to think we're just at the beginning of all this.
Absolutely. And remember, M87 is just one supermassive black hole. There are billions more out there, each with its own story to tell.
That makes me wonder, if M87's disk is this turbulent, does that mean all black holes are surrounded by this crazy chaos? Or could there be some that are, a bit quieter, more organized?
That's a great question, and one that astronomers are trying to figure out. It's possible that how turbulent the disk is depends on a few things, like the black hole's mass, how fast it's spinning, and how much gas and dust is around.
So while M87 gives us this amazing look at one black hole, it also brings up a whole bunch of new questions about all the different types of black holes out there.
That's the thing about science, isn't it? You answer one question, and it leads to, 10 more. It's a humbling realization. We've learned so much, but there's still so much we don't know.
Makes you feel kind of small, doesn't it? But also excited about what we might discover next. The EHT team, they're already working on data from 2021 and 2022. What do you think we'll learn from that? What other secrets is M87 hiding?
Well, one thing's for sure. Every time we get new observations, our picture of this black hole becomes clearer. And as we keep getting data from M87 and other black holes, we'll learn even more about the incredible processes that shape our universe.
It's pretty amazing to be alive to see all these discoveries happening, isn't it? Feels like we're entering a whole new era of black hole science with the EHT leading the way.
I think so, too. The future of black hole research is bright. Can't wait to see what we uncover next.
Me neither. So as we wrap up this part of our deep dive into M87, what would you say is the most important thing for our listeners to remember? What's the big takeaway from all this?
I think for me, it's that, black holes aren't these still unchanging things. They're dynamic, always evolving, always interacting with what's around them. And that turbulence in M87's disk, it really shows that.
Right. It's not what we used to think about black holes, just sucking everything up. It's way more complicated and way more interesting.
Exactly. It's not just destruction, right?
Yeah.
Black holes are actually super important for how galaxies evolve, how stars are spread out, even how new stars are born.
Yeah, that's wild. But it brings up a question, from that M87 research. If its disk is so turbulent, are all black holes like that, surrounded by all that chaos? Or are there some that are, more chill?
That's the big question, isn't it? And astronomers are working on it. It could be that the turbulence depends on a few things. The black hole's mass, how fast it's spinning, what kind of stuff is around it.
So M87, it gives us this incredible look at one black hole. But it also shows us how much we still don't know about all the other black holes out there.
That's what's so great about science, right? You answer one question and you end up with a million more. It's humbling. We've come so far, but there's still so much to discover.
Yeah, it's kind of overwhelming, but in a good way, Makes you realize how much is out there. But hey, the EHT team, they're not stopping. They're already looking at data from 2021 and 2022. What do you think they'll find? What other secrets is M87 hiding?
Well, every time we get more observations, our picture of M87 becomes more complete. And as we keep studying it and other black holes, we're going to learn even more about how the universe works, the stuff that makes it tick.
It's amazing, isn't it, to be living in a time when we can see all this happening. Feels like we're at the start of something huge for black hole science, with the EHT leading the way.
I agree. The future of black hole research is, well, it's wide open. Can't wait to see what comes next.
Me neither. Well, I think it's safe to say that we've all learned a ton from this deep dive into M87. Turbulent disks, gas going in different directions, the connection between black holes and galaxies. It's been mind-blowing.
It really has. And with the EHT team on the case, who knows what amazing discoveries are just around the corner.
Exactly. So to everyone listening, remember, the universe is huge and it's full of amazing things. So never stop exploring, never stop asking questions, and never lose that sense of wonder. Thanks for joining us on this deep dive into M87. Until next time, keep looking up and keep exploring the cosmos.